G'day, thanks very much for checking this one out. My name's John Martin, I'm the Principal Technologist at NetApp, and I'm going to be talking to you about why you should ditch the LUN. The quote which I have, which you should see in the little screen up next to me, is a quote from a gentleman by the name of John Tering. I stole a whole stack of his work and then produced it in a blog that I wrote for Computer World. If you're interested in that blog, just go to Google and look up Ditch the LUN and Computer World and maybe my name, John Martin. I don't think that last part's really necessary, but I really liked that particular quote, which was that the LUN is just plain nasty and your mother definitely would not approve of you using it. It came from something that he wrote back in 2009 when virtualization was still pretty wacky and barely being used in the enterprise. And he said that the thing that we really needed to do to take virtualization to the next level was to ditch the LUN. And a lot of what I'm about to talk about is put into a lot more detail inside that blog post. But yeah, if you read it and you read the original article that he wrote in Computer Measurement, you'll understand exactly why this is the case. So, back around about 2009, virtualization broke the SAN. That's not to say that SAN stopped being sold, but managing SAN suddenly became a lot harder. In the old school, like, each application tended to have lots of different LUNs. So you might have a RAID 10 LUN for your log files for an Oracle database. You might have RAID 5 for certain table spaces, RAID 10 for other table spaces, maybe, God forbid, RAID 6 from other vendors for some other low priority data. And that worked pretty well. Then along came virtualization. And VMware is awesome, and virtualization is awesome. And the VMware data stores, on the other hand, are perhaps my least favorite portion of virtualization. They kind of broke that whole paradigm of an application having multiple LUNs, and now instead of having one application fanning out to 3 or 4 or 5 or 10 LUNs, you now have 10 or 20 applications, all of which converge into one single LUN, one single object sitting inside the storage array, which pretty much defeated every single optimization technique storage arrays had built over the last 10 to 20 years. Some people refer to this as the I/O blender effect. Pretty much everything became random and really, really hard to predict. It just looked like a completely different set of workloads. So things like NFS, using NFS data stores for VMware, and I really think that when VMware allowed you to have an NFS data store, I think they were really thinking that it would be good for like ISO images, and that was about it. But NetApp being a sort of fairly NFS-centric organization, as much as we love block and as much as we love LUNs ourselves, a lot of things were just a lot easier when you did things on NFS. And part of the reason for that was that every single VMDK or every single virtual disk looked like a separate object that we could track. We understood the I/O patterns that were coming to that, which really allowed us to be able to keep the optimizations that we'd had for the last 10, 15 years. It also made the system a lot easier to manage. I mean, you don't manage storage, you actually manage storage containers. Nobody manages a terabyte. What you manage is a LUN or a VM data store or a directory. It's these storage containers that you manage. And this is one of the things that John Tering was actually going on about, is the fact that the more containers you have, the more pools of storage you need to manage, the harder things get, and the more you get outages from lack of space, the more time you spend provisioning, the more time you spend in change control. And this was the basis of him saying that LUNs were evil. So if we go into this in a little bit more detail, you see how traditional VM data store, and it's not just VMware data store, the same thing is true of cluster shared volumes in Hyper-V, the same thing is also true in Xen Server, and I've completely forgotten what Xen Server calls their pools, but it's the same kind of thing. When you use a block device to hold lots and lots of smaller logical devices through some kind of internal file system on the virtualization layer, you end up with a single queue coming down to the array. Now that queue in a storage world is typically about 64 operations that can be sent at the same time. What that does is it really limits the parallelism of what the underlying storage array can do. So again, it kills the optimizations that the array is allowed to do. in a traditional world, when you want to be able to, like a physical server world, when you want really high performing LUN, you'll give that LUN a queue depth of like 64 all by itself. Now we're sharing that one queue depth amongst lots and lots and lots and lots and lots of different applications. Sometimes when people say that they would like to have like a multi-terabyte, like 16 terabytes or 20 terabytes as a LUN which is provisioned up towards a VMware data store, I just shake my head, because they're setting themselves up, regardless of how fast the underlying storage is, for some kind of performance problem, right? And that's one of the big things that we see quite often when people are having performance-related issues with storage. It's because of a lack of queue depth, especially inside of block device. And this, again, is true for both Fibre Channel and iSCSI. So that's the technical challenge from us. And I think the bigger problem is really that around the management and the disconnect between the storage guy and the VM guy. And the VM guy is a lot closer to the application guy, and they just want results quickly. But the trouble is, for the most part, they were only ever able to define things like quality of service on like network layers or on the CPU layer, right? It was really hard to do service level objectives for storage. There was a limited number of data stores that you could have per app, and each one of those data stores, while they might be on a different class of storage, it's a really, really kind of coarse-grained way of doing like storage management, application like SLO management. And on top of that, the data management things like doing snapshots and stuff like that were then determined on a per VM basis, with very little, if any, ability for the storage admin to be able to tune that or understand what the hell's going on. So he has no idea how his storage is being used, which doesn't make him feel happy. He's not able to offer any SLOs per application anymore. He's not able to say, well, this particular LUN gets synchronous mirroring. And yeah, you can kind of do this if you spend a long time up the server virtualization layer, like mapping out your data stores and like figuring out which VMs, which portions of VM disks belong on what data stores. But from my experience, nobody actually did that well, because it was just too damn hard. And again, the trouble is that you end up with this massive I/O blender situation, which just presents stupid amounts of really, really, really random I/O that's really hard to optimize at the storage array level. So again, you're buying something that's got a massive, well, at least in the case of NetApp, it's got an awful lot of intelligence. It just makes it really hard to make use of that while it's hidden behind this opaque like data store layer. And when we translate that back into like how do we then set up an array to take advantage of VDI or end user computing or whatever you want to call it, you see stuff like the things you see on the screen, right? Lots and lots of little islands of storage, each one of which micromanaged, each one of which required prior planning, and generally speaking, none of which are able to really share the resources of the disks or the IOPS that belong to one of those disks or the SSDs with the other things. And this is fraught with danger, because the thing about IT is that these kinds of designs that you see assume that you know exactly what your workload is going to look like over the next 6 months, 8 months, a year, 2 years, 3 years, right? Nobody has that kind of visibility. If I was that good, if any of us were that good at predicting the future, we wouldn't be working in IT, we'd be millionaires having made our money on the stock market. So this is just kind of broken. What I think you should be looking at is something that looks a lot more like this. And this is the NetApp VDI architecture for a relatively small number of virtual machines. We can do this at around about sort of $35 a desktop, big plug for NetApp. But the point is, it's a layer of disks, one fairly large global pool, right? And a layer of solid state. In our particular case, this is showing you a product we have called Flash Cache. We could also do it with something called Flash Pool. Or you could do this and separate out that flash caching tier and drop that directly up inside the virtualization layer. And again, VMware has some great ways of doing this. There's some really great stuff with Citrix with their PVS capability to do similar kinds of things that minimize the amount of stuff which ends up at the storage layer, but also tends to make what hits disks really, really write intensive. And you you can end up with a whole bunch of problems unless you go through and globalize your pool to take advantage of the increasingly small number of IOs that you have available to you at the disk layer. Because for the foreseeable future, hybrid technologies like the one we see here, or what you might see inside of, say, vSAN or the PVS stuff, or any of the rest of the things, this is the kind of architecture you're going to see. But you also need to have some way of taking care of that I/O blender situation, especially on writes, because again, coming back to that end user compute, when we first moved to Windows 7, my God, the read-write ratio is just completely turned on its head compared to what we saw in database environments. So I'm just going to come back to this one. Typically, I've had a PowerPoint challenge, but the idea here is that you end up with lots and lots of different kinds of things, and if you give the storage management layer a half a chance, it'll do really intelligent things to optimize that stuff, especially for disk, right? And this is something where I think some of the newer technologies are still trying to play catch up. This is where, like, having 20 years of technology and experience in this area really makes a big difference. But being able to go through and take that I/O blender and use some intelligence to be able to turn that into something which is optimized is going to be a key feature of all storage technologies related to virtualization going forwards. So if we think about this and we think about what is the ideal storage pool deployment, what does it look like? And in many ways it looks a lot like the early NFS and CIFS implementations that we saw in VMware and with Hyper-V once they finally got around to supporting SMB3. And that is that you have, each disk has its own queue back to the storage environment, wherever that happens to be, okay? And that while we talk about having one big pool, a lot of that is one big pool to manage. It doesn't necessarily mean it's one big physical pool, because just because you can throw everything into one great big huge physical failure domain doesn't mean it's a good idea. In fact, I've seen some recommendations where people are suggesting perhaps that you can reduce your VM level of protection down to 1 and then dropping this onto a distributed storage pool. And in the end, you end up with an availability which is worse than just dropping it onto a single disk. So there are still design considerations at the physical layer, and that's where you still want to have somebody who understands storage and cares about storage and data management deeply. It's the reason why you want to be working with storage-related vendors or your local storage subject matter expert. But once you've figured out what that looks like, you can then use the intelligence of a well-designed storage pool to be able to define your service level objectives, not just for your memory and your compute, but also for storage as well. And a lot of this can be pushed all the way up into the application layer, because in the end we're starting to see things like Docker coming in and other stuff where the application admins are wanting a lot more control or want to set a lot more policies at the application level, which will drive themselves all the way down into the infrastructure. Data management operations become per application, and again that stuff can be delegated back through to the area which is able to make the best use of it. So again, taking advantage of the principles of software-defined infrastructure, where you have things which define policies and things which implement those policies, and the things which implement those policies are built and designed to implement those policies in the most efficient way possible. And in the end, the storage admin's job becomes a lot easier because he's able to concentrate on the stuff that makes his thing a lot better. He publishes storage level SLOs associated with each capacity pool. And those capacity pools can be spread across geographic areas. You can design them as a scale-up solution or as a scale-out solution. It doesn't really matter. The implementation detail is hidden behind the concept of the storage pool. And you end up with granular control over conformance, not just for performance, but also for data protection, physical locality, which is becoming more important as we're starting to move into cloud-based solutions where people are going to want to know that that particular piece of data or that particular application is residing within a particular jurisdiction. And the key thing here is that you're able to go through and define those storage level SLOs up at that higher level. So from a NetApp perspective, the way that we implement this is through something which we refer to as the storage hypervisor, which is something we've been working on for what must be almost 10 years now, and takes a lot of the work, a lot of the experience that we had with VMware, takes a scale-out infrastructure that we brought in through a acquisition called Spinnaker, and actually brings this together into something which we refer to as clustered data on tap. And we do this not just for VMware, with upcoming things like vVols and all the rest of that sort of stuff, which I would love to talk about, but I can't because it's still NDA. But makes it available for physical infrastructure, makes it available for other forms of virtualization and other kinds of cloud environments as well. So again, the idea is to provide this concept of the storage pool, which has limited failure domains, and provide policy-based management and service-level objective-based management, and provide interfaces up through into the orchestrators like VMware that allows them to take advantage of those resources at the bottom end. Net result is you're managing a pool, not specific technologies. So, you know, I'm not going to read through this because I'm assuming that you can actually read by now, but the main things I like about this is that it drives an awful lot of flexibility, and I've gone through this in more detail inside that Computer World blog post, which I'd sort of encourage you to go and read, even if it's just to bump up my hits on that site. But the thing about it is that everything becomes far more software defined, far more policy defined, and far more changeable on the fly. You can grow things and shrink things on the fly. You're no longer limited by the physical constraints of a LUN, because a LUN, even though it says logical unit number, which is what LUN stands for, the logical part of it really isn't that logical at all. It's very, very heavily tied down to physical implementations, even to the point where things like disk geometries are kind of inferred by certain kinds of LUNs. Okay? So going through and thinking about your underlying storage environment in terms of policy-based decision making and promise theory and a bunch of other really cool things, this storage pool concept is one of the key enablers of this, providing you have programmatic access and it's exposed up through APIs like Vasa and those sorts of things up through into your orchestration system. So if you've gone through and you've listened to this and you're wondering what the next thing you should be doing, if you're a NetApp customer, hell, even if you're not a NetApp customer, if you're interested in the vVols beta and you would like some storage that looks and acts and smells and feels like something that actually supports this with a really rich set of application and policy domains, policy settings that you can actually do things with inside of vVols, go and register on the vVol beta for VMware, and then try and get access to the current version of ONTAP, which actually supports all of this. And you can run this inside of a simulator. You can run it. A lot of our people just run this on Horizon, on their Mac. What's Craig? What's the virtualization? No, not Parallels. That's Fusion. Thank you. Yeah, Fusion for Mac. A lot of us run this stuff on Fusion for Mac. And it's pretty easy to do that. You can run pretty much an entire vVol beta just on that, just on a laptop. So that's something which I would suggest you do. I've given a couple of links here to where to go and access this stuff. There will be some cookbooks and some stuff from NetApp. If you're, again, not a NetApp customer, you can go through, register on the NetApp support site, and go and talk to somebody friendly like one of our resellers, and we should be able to get you that stuff. At Insight Berlin, if you're listening to this and you're based somewhere in Europe, go to Insight in Berlin. There will actually be a really good session on exactly this, and we'll actually be deep diving and actually revealing a lot more about our vVol capabilities then. And if you're a VMware customer, which again many of you will be, and have access to the vmworld.com, I'd strongly recommend you log into the vmworld.com and get access to those vVol deep dive sessions, because while the storage pool concept is hardly new, I would say that what we're seeing with vVols is probably going to be the best implementation of being able to exploit this through programmatic APIs that you'll see for quite some time to come. And with that, I think I'm probably a little ahead of my time, but thanks very much. And remember, it's time to ditch your LUN.